Yeah, why not? Okay, so we do have a PowerPoint presentation, which I'll just show you here very quickly. It's about single table queries. The idea in this presentation, and again, I made a video about this, so I'm going to go through it really, really quickly, I think, because you can go through the video, which is, yeah, I'm going to use different words this time. This is all just off the top of my head. I hope that's all right. But we're going to talk about retrieving data, and I hope you get the idea of the columns and the rows. The columns and the rows. We use select for columns. We use where for the to narrow down the rows that we want. But we've got all of these other things that we can do. We can when we're in the where, we can limit the rows that we're going to get by using a range, which would be between. We can use like to expand the range, I suppose, a bit, because like allows us to have wildcards where we can say, for example, all the things that start with A. So we can say like A%, that would be all the things that start with A, or we could say like percent A, which would be all the things that end with A, or we could say like percent A%, which would be all the things that have A in the middle. We can have an in allows us to have a list and to accept anything that's found within that list. And so I hope all of these things will sort of make sense to you as we look at this sort of quickly today. Good afternoon, everyone. So we have a sort as well. Now the sort, we can sort on multiple columns within a table. Now, bearing in mind, and I hope you got this idea from what we said before, that the results of any SQL query are always going to be another table. So we select data from table or tables, it could be multiple, but the result is always going to be another table. And in that table, we'll have different columns, the fields, and we can sort on any of those columns. We can sort on multiple of those columns. And when we do sort on multiple, we sort on one first and then the next and then the next or whatever. And so we refer to those as our major and our minor or sortings. We can sort ascending or descending. Ascending just means from small to big, and descending just means from big to small. And aggregate functors, they're just things like we can add up things. So we can do a count, or we can do a sum, or we can do a average, or the minimum or the maximum. Null value, the idea there is you can have a field which is not forced to have a value in it. And we can see if a field has a value in it or not by checking to see if it's null. So all of those things are possible. So what is a query? We use the word query. I hope it sounds familiar. The idea of SQL is it was supposed to be user-friendly, fourth generation language, blah, blah. The idea was that we're supposed to be able to interact with a computer kind of in the way that we interact with other human beings. And so we had this fourth generation programming language, which was SQL. A query is that as if we went to the computer, and this seemed really far-fetched and futuristic back in the 1970s, but as if we went to the computer and said, ask the computer a question, and in almost an English-like way, and the computer responded with an answer. And so SQL, we are allowed to say, select from this data, which is in a table, all the things where these conditions are true. And so that's kind of like English, I guess we could say. And so, yes, this is the basic structure of a SQL query, structured query language query. Select, we can list all of the columns in a table that we want to get the data from. From, we name the table that we want to select those columns from. Where, we limit the rows with the where clause. We limit the rows, or we filter the rows, or we say which rows we want to include or exclude. And the where clause is optional. I hope that you get the idea that if we didn't have a where clause, that would mean that we would get all the rows. If there was no where clause, it would get all the rows because there would be nothing to limit the rows. So the select statement, we can get, as it says there, specified columns and rows. The columns are chosen by the thing that follows the select immediately, and the rows are chosen from the where. And the where can be compounded, and you'll see how we compound those. If you don't have a where, then we get all of the columns. So here's an example. Select the customer number, customer name, and balance from customer. What this does is it gets all the rows because we don't have a where, but we don't get all the columns. we only get the columns that are specified, and we get those columns in the order that we specified them. So we put customer number first, then customer name, then balance, and that's how the values are displayed. And those are all of the rows from that table. The asterisk is a wild card. Wild card means we'll accept any value. So when we say select star, it means just get all the rows, all the columns. If there's the where is what determines what rows we get, remember. Um, yeah, so there we can use a star, and I think we got an example of that coming up. Yeah, select star from part. What this does, because there's no where statement, and because we said select all the columns, so the star there means select all the columns, and because there's no where statement, we also get all the rows. So select star from part will show you the whole table, all the values in that table. Select star from. The where clause limits the rows. We can call it a filter. And so we put conditions in the where clause to limit the rows. So here's an example. We're limiting the rows, the only rows that we can have. And by the way, we haven't just limited the rows here, we've limited the columns as well. Thanks for that little drawing, Carlos. I'm not sure why, but that was nice. So here we're only going to get the customer name, and we're only going to get the customer name when the customer number is 148. And so this gives us a very small result. Now remember, all the results are going to be in a table, but this is a very small table. A table can just have one value in it, one column and one row. Now, when we use our where clause, the conditions can have this, what we call relational algebra applied to them. I'm sure you're familiar with the term algebra, replying to, that's okay, Carlos, I'm only, you know me, I'm just teasing. It's all right. So relational algebra is used for comparing things, as it says. So we can compare things and see if they're bigger than, less than, and we have some not equal to, bigger than, or less than, those things. So that's our part of our relational algebra. Now, a simple condition would be a where clause by itself. We can have compound conditions where we add something to the where clause, and we'll see that later. So here's a simple condition. The simple condition is the balance is bigger than the credit limit. Now, I hope that you can see here that balance and credit limit are two different columns within the same table. The balance is numerical, and so is the credit limit. And so the only values that will be retrieved from this command, we get these columns, customer number, the customer name, the balance, and the credit limit from the customer table, but only if the balance is bigger than the credit limit. And if you look at those, you'll see that that's true. There are a lot of other records in that table, but they will not be shown, only the ones where this simple condition is true. With compound conditions, we can add something to the where clause, and we can add things with an and, or an or a not. And I hope that you get the idea. With an and condition, that means that two things have to be true. So an and condition is always going to restrict the number of rows even further, because two things have to be true, not just one thing. Two things have to be true, and it's less likely for two things to be true than it is for one thing to be true. I hope that makes sense to you, right? Okay, so in this case, we're only going to select one column from the table, and in that, it will only be a value where the warehouse is from warehouse 3, but also it must be that the on-hand value is bigger than 25. And it turns out that there's only one record which meets that condition. Apparently, only iron is found in warehouse 3, such that such that the on-hand value is bigger than 25. Now, have a look at this, and you'll see, and I'll just go back. I'll try to. So look at this command, and then look at this command. They are almost exactly the same. There's only one difference between the previous command and this command, and that is we've changed the and for an or. And it makes a totally different result, because in the previous one, both these two things had to be true to get the result, and the result was a single row. In this one, either can be true. So it's not just that we have to have the value of 3 here, and we have to have the value of 25 here. Either one can be true. If this value is 3, then it will show up. And that was the value where we had iron, for example. Or if this value here on hand is bigger than 25, then it'll show up. So we get a lot more results. So or is going to expand the results that we have a little bit. Now not, we can use not in a compound condition. What not will do is give us all the values where the thing that we're saying here inside these brackets is not true. And so in other words, these would be all of the things where the warehouse was not 3. So like where warehouse was 1, 2, or 4 or whatever. All right, so we can have a range of values using between. So between 2,000 and 5,000. The only things that so that we're narrowing down the rows that will be shown here. We only have these columns, there's those columns, but the balance must be between these two numbers. And if you look at those balances, you'll see that that's the case. Now, a computed column, what we can do is if we got numeric values, especially, this works very nicely with, we can take the numbers and manipulate them a bit. We can add them, subtract them, multiply them, or divide them, and come up with a new number, and then we can select that. So what we've done here is we know that in this table, we have two columns that represent money. One is a credit limit and one is a balance. We can subtract one from the other and return the value of that calculation. And so that's what's happened here is we're selecting the customer number, the customer name, and instead of selecting one of these, we're selecting one minus the other, and we get this number. Now that produces this strange looking heading. The heading is just as we selected it, and that's kind of ugly. And so what we would typically do is that we would make an alias for this credit limit minus balance. And that's what's in the next slide is we say, okay, we're going to get the credit limit minus the balance, but we're going to give it a new name. We're going to call it available credit. And so we get that value, which is credit limit minus balance, but we call it available credit. And so available credit is the heading on that column. The like operator allows us to use wildcards so that we can get, for example, all the values that start with A or all the values that have central in the middle of them. So this has got a percent on either end. The percent at the start means that we don't care that what happens before central, as long as central's there. The percent at the end means we don't care what happens after central, as long as central's there. So for example, this would return a value 3829 central or the value centralia. As long as central is there, it will show it. Now, another thing that we can do with the like is we can put an underscore between two characters, and then that doesn't matter what happens in that position. So like T underscore M is going to give us, oh, sorry. Yeah, is that back there? Yes. T underscore M is going to give us all these values, Tom, Tim, whatever. All right, so here's the central one again. We got a percent before and a percent after. We got the like. And so what this is going to do is give us all the values that have central somewhere in the street. And what do we got here? Here we have a list. We have a list of 3 values. As long as our credit limit is one of these values from the list, then that record will be shown. And these are the fields that will be shown. So, for example, all of these values here are within this list, 10,000, 5,000, and 15,000. As long as the credit limit is within that list, then it will be shown. Order by is for sorting. Sorting, the default is from small to big. We talk about major and minor, and that is shown in this example. In this example, we have sorted. The major sort is done by credit limit. So that's the first thing that's sorted, right? And the minor sort is done by customer name. And if you look at this, the credit limit has been sorted in descending order. We had to say descending order. The customer name has not it doesn't have a descending or an ascending beside it, so the default is ascending. And so how does this work? So the major sort happens first. The credit limit is sorted in descending order, so the biggest credit limit down to the smallest credit limit. Then within where we have the set of credit limits are all the same, then the minor sort comes into play. And so for all of the 10,000s where that credit limit is the same, those things will be in alphabetical order inside the 10,000. And then the next one is the 7,500s. They are within alphabetical order within the 7,500. But notice that Al's Appliance comes after Johnson Department Store, and that's because Johnson Department Store was sorted. It has the 10,000. It's got to have to happen before Al's Appliance because the credit limit was the major sort. These are our aggregates, average, count, max, min, sum. And so what you can do, you can limit the rows that they affect, but what they are going to do is just return like a single row, but based on the rows that you have applied them to with the where class. So this count is only going to be for the records where the class is HW. And so that's what this is telling us, that there's 3 records where the class is HW. Works with numeric fields. And so here's a nice one where we are selecting the total, the average, the max, and the min, and all from all of the records because there's no where clause there, right? So this is going to give us those, and yeah, those values, but so that's cool. And the null, the idea of the null is you can force, when you create your tables, you can force them so that they don't accept null values. But on the other hand, if you don't force them to not accept null values, maybe they can, and we can test to see by checking is null. So where street is null, apparently in our database for customer, we don't have any records where there's no street, but it may be allowed. Now update, what update is doing is you are actually changing the data in the table. And so how we do that is, this is the syntax for that. We say update the name of the table. Then we say set the column or the field name to whatever the value is that we want. And notice here we've got multiple field names, so we could do all of the fields in that record, or we could just do 1 or 2 of them. So all we've done here is change 2 fields, the address, the customer name, and their address, their city. And then we've got a where clause. This is quite important, I guess, where the customer ID is equal to something. So if we didn't have this where clause in there, it would change the names and the city for all the records. Which is probably not a great idea if we want our database to stay meaningful. So usually we'd have to look at that where clause pretty carefully. We have this other command, which is called the alter table command, which allows us to do things like add a column, remove a column, change a column name, all of those things we can do to a table which already exists. And so it could happen that for some reason you decide that after you've got your database with all your data in it, even, that you need to add another field, and you can do that with alter table. And there's our summary of what we talked about there, and I hope that all makes sense. I did go through that very quickly, but I did go through that also. There's a video on it as well, so I think you've got plenty to sort of look at there. Now, I also made a video on how to answer these questions, and you've got 10 questions there that you have to answer. The idea is just to answer the Word document by typing the result that you need. And it's not even an SQL command, right? So for example, how do we do this one here, create a table in SQL? You just say you use a create table command. How do we delete a table? Drop table. What are the common data types? Well, you need to probably do a bit of a Google on that. W3 schools. Well, let's see, I mean, I just want to make sure I don't forget anything here. So what I would do if I was you is I would go to Google, and where's Google here? Yeah, here. And I'd say, okay, W3 schools. Then I would say, I might even put the search in here, right? And I would say SQL data types. And you'll find your answer pretty quickly. Well, I mean, you could navigate to, yeah, you could navigate to W3 schools and then do the search there, because W3 schools has its own search feature. But yeah, so there we go. That would give you a nice answer of all the, so nice little table even, right? Here's all, so you can take that table and stick it in there as your answer, I suppose. But it would be better if you sort of read it and tried to understand it, right? So yeah, you've got the ones that we've used already are char and varchar. We haven't used binary. That's kind of nice, I suppose. And you could sort of blobs and tiny text, and then the size of the text. It's kind of like char. How's that different? And we can have a set. Oh, look at enumerated values. Then we got a bunch of numeric values there. The one we've used, we used, we didn't use int or integer. We used, wow, these ones here, it's got double and float, and we've just used numeric. So it seems there's a couple of different standards here. Um, so those are there. Look at, we got several different types of date values. Okay, and there's a bunch of string types. Yeah. Okay, so yeah, numeric. That's the one that we used. So there's a lot of help there for you in W3 schools. Certainly enough to answer that question. Common data types. Use so choosing the best data type. If you want a month, day, and year, I think if you go back and look there, you'll find one there that's good. You know, it's going to be date, time, or something like that. Employee ID number, probably just going to use char. The Department of varchar would work for that. Hourly rate would have to be one of these numeric ones, and you could decide which one. And I'm not going to go through all of those, so I think yeah. Anyway, so that's kind of what it is today. We do have limited time, so I'm going to stop talking about that now, and maybe somebody has any questions or whatever. Do you? Are we good? So that's the exercise that I want you to do. Yes, go ahead, please.